Next is Butterworth high pass filter. In the last video, we have discussed Butterworth low pass filter. Basically, this is a first order Butterworth high pass filter, right? So this is the circuit diagram for this high pass filter, and this is the frequency response. So first, high pass filter means what? It is one of the filter which passes the high frequency and blocks or attenuates or reject low pass frequency, the low frequency, right? High pass filter is a filter which passes the high frequency and reject or block or attenuates the low frequency, right? So this is the circuit diagram for high pass filter. So how this circuit diagram is constructed, right? If you observe carefully, in the last video we have discussed this is a low pass filter, right? If you compare the circuit diagram for the both, so this is your RC network, and this operational amplifier works in a non-inverting mode, right? Observe carefully. So this RC network is interchanged in a high pass filter, right? Means what? High pass filter can be constructed by interchanging the value of by interchanging the resistor and capacitor, right? So here is a R, here is a C, here is a R, and here is a C, right? So this interchanging of this resistor and capacitor which forms the high pass filter from the low pass filter. Next is comparison for frequency response. So this frequency response is for low pass filter and this frequency response is for high pass filter, right? So look at here carefully. In a low pass filter, the here is a pass band and next is a stop band. So here is a cutoff frequency FC and here is also cutoff frequency FC, right? We discussed Butterworth means what? In Butterworth case, right, in Butterworth the frequency response is flat over the passband region. Frequency response, this frequency response is flat over the passband region, and here also same, the frequency response is flat over the passband region. That is a Butterworth. But in this high pass filter, the gain is going to increase when the operating frequency is going to increase, right? So this gain is increases at the rate of plus 20 dB per decade, and in low pass filter the gain was decreasing at the rate of minus 20 dB per decade. So this is the main difference between these frequency responses of the low pass filter and high pass filter, right? I will repeat, the gain is going to decrease when the frequency is going to increase in low pass filter. The gain is going to increase when the frequency is going to increase in the high pass filter. The increasing rate is plus 20 dB per decade and the decreasing rate is minus 20 dB per decade, right? So this is the comparison between the high pass filter and low pass filter. The value of this cutoff frequency FC is determined on the basis of or from the value of R and C. So this is your RC network, and this operational amplifier works as a non-inverting amplifier or non-inverting mode. So this RC network, it consists of resistor and capacitor, right? The cutoff frequency is determined with the help of value of R and C, and the closed loop gain or the gain in pass band can be determined with the help of resistor R1 and feedback resistor RF. Okay, so in this frequency response, first is the stop band, second is the pass band, right? Means from this frequency response we can conclude that the frequency which is greater than cutoff frequency fc, the frequency which is greater than the cutoff frequency fc, that will passed by the filter and remaining frequency will block or rejected, right? Means the frequency above this cutoff frequency is a high frequency, and that high frequency is passed by the high pass filter and it rejects the low frequency. Okay, so next is we have to derive the output voltage v naught, right? Also we have to derive the voltage gain, that is v naught by v in, right? After that we have to conclude three conditions to know the operation of this high pass filter. To derive this output voltage v naught, to derive the voltage gain of the high pass filter, first we have to derive the equation for v1. Okay, equation for v1. After that we will find the output voltage v naught and its ratio v naught by v in. So to find this v1, use the concept of voltage divider. By using the concept of voltage divider, by voltage divider, so this v1 is equal to v1, see here, right? So this v1 is equal to r upon r minus j xc, right, into its input voltage v in. But as you know, this minus jxc is equal to 1 upon j 2 pi fc. So substitute this equation in above equation. So this v1 is equal to r upon r plus 1 upon j 2 pi fc into v in. Okay, so after that, taking its LCM, all these things, so equation becomes r into j 2 pi fc upon 1 plus j 2 pi frc into v in, into v in. As you know, this cutoff frequency fc is equal to 1 upon 2 pi rc, right? So substitute substitute 2 pi rc is equal to 1 upon fc. As you know, the cutoff frequency fc is equal to 1 upon 2 pi rc, right? So v1 become is equal to j into f upon fc upon 1 plus j into f upon fc into v in, into v in. So this is the voltage v1. Okay, now we have to obtain the output voltage v naught. So as you know, the output voltage v naught is equal to the gain into its input voltage. that is, a gain is a closed loop gain, that is it works in a non-inverting mode. So that's why the closed loop gain is 1 plus Rf by R1 into V1 into V1. Input voltage is what? V1. So substitute this V1 in this output voltage V0. So this output voltage V0 is equal to 1 plus Rf by R1 into J into F upon Fc upon 1 plus J into F upon Fc into Vin. Okay, now we have to derive the voltage gain, that is what output voltage V0 upon input voltage Vin. So this becomes V0 upon Vin is equal to, and this 1 plus Rf by R1 is a closed loop gain or passband gain, which is equal to AF. This becomes upon 1 plus J in remaining part, J into F upon Fc, right, into J into F by Fc. Okay, so this is the voltage gain V0 by Vin, right? So we can say this is the equation for gain of a first order high pass filter, right? So the next we have to find the magnitude of the filter gain. So to find the magnitude, so we have to take this equation in a magnitude and a phase angle, that is V0 by Vin is equal to AF upon root of 1 plus Fc by F square, right? So this equation is a magnitude of voltage gain. So this is the magnitude of voltage gain, or the voltage gain of first order high pass Butterworth filter, right? Where this F is the operating frequency and this Fc is a cutoff frequency, right? So in this way, so this is called as an Butterworth high pass filter, which is a first order. Okay, now from this equation we can take the three conditions or three operations of the high pass filter. Number one, when the operating frequency is a very low, that is when F is less than Fc, operating frequency F is less than Fc, right? So that time the magnitude of voltage gain is less than AVF, is less than AVF, right? This is the first condition. Next, when this operating frequency F is equal to Fc, that is the cutoff frequency, right? So from this frequency response we can say when the operating frequency is going to increase, the filter gain also is going to increase, right? So when the F is equal to Fc, the voltage gain magnitude V0 by Vin is equal to 0.707 AVF. So this, when this F is equal to Fc. And for higher frequencies, right, when the F is greater than Fc, operating frequency is greater than cutoff frequency, then your gain is a flat, or your gain is a constant, that is equal to AVF, that is a constant. So this region is called as a low frequency. This region is called as an high frequency, where this high pass filter will pass the high frequencies, which is called as an pass band, and this is the low frequency, where this high pass filter blocks or attenuates the low frequency in this region. That's why here the gain is going to increase at the rate of plus 20 dB decade per decade, right? Whereas in a first order low pass filter, the gain is going to decrease by minus 20 dB per decade, right? So such type of high pass filters are used in various applications, right? It is also used, or it helps in a removal of noise. After that, it is also used to sharp the image, right? Like this, various uses are there for this high pass filter. Okay, so this is called as a Butterworth high pass filter. In the next video, we will see the second order Butterworth high pass filter. Thank you for watching this video. And if you like my video, please subscribe my channel and press the bell icon for latest video notification. Thank you.